Progression. Sequence quantities called terms in which relationships between consecutive terms is the same. The first type of progression is arithmetic progression. An arithmetic progression is a finite or infinite sequence of numbers which is a property that difference between any two consecutive terms of the sequence is constant r. Hence that a1, a2, and the value of an is arithmetic progression if only if there is constant r, that a subscript of 2 minus a subscript of 1 is equals to a subscript of 3 minus a subscript of 2 equals r a subscript of n minus a subscript of n minus 1 is equals to r, or equivalently a subscript of 2 is equals to a subscript of 1 plus r a subscript of 3 equals a subscript of 2 plus r, and a subscript of n is equal to subscript of n minus 1 plus r. Remember that the nth term of an, or the general term for an ANAP, is an a plus n minus 1, where a is the first term and d is the common difference. Note that a raised to 1 is equals to the sum of s subscript of n of the first n terms of an AP is given by Sn is equals to n over 2 to the value of 2a plus n minus 1 times d. If 1 is the last term of AP in terms, then the sum of all terms can be also given b. S subscript of n is equals to 2 subscript of n plus the value of a plus 1. Sometimes S subscript of n is also denoted by, if S subscript of n is the sum of the first n terms of an AP, then it is the nth terms and it's given by a subscript of n is equals to S subscript of n minus subscript of n is equals minus 1. In an arithmetic sequence, the difference between one term and the next term is constant. For example, 1, 4, 7, 13, 16, 19, 22, 25, and so on. This sequence has difference between 3 between each number. Its rule is a subscript of n is equals to 3n minus 2. We just add some values of each time to infinity. Examples 2, 5, 8, 11, 3 is an arithmetic progression in which 5 terms and the common difference between successive terms is equal to 3. So, and 3, 1, negative 3, 5, and 7, 2, 2 is a constant arithmetic progression in terms, and the common difference between successive terms is equal to 0, 2, 4, and 8 is an infinite arithmetic progression with common difference between successive terms equals to 2. Example, in the first 3 terms in arithmetic progressions are 3, 7, and 11, then what is the nth term? So, in solving that problem, the first term is a equals 3 and the common difference is 4. So, you need to identify the first term and their common difference by subtracting. So, the common difference is 4. U subscript of n is equals to a plus n minus 1 times d. So, U subscript of 10 is equals to 3 plus 10 minus 1 equals 4. 3 plus 9 times 4 is equals to 39. Note that you must use PEMDAS in solving. If the first 3 terms in arithmetic progressions are 3, 7, 11, then what is the sum of the first 10 terms? Note that a is equals to 3, common difference is equals to 4, and n is equals to 10. So, S subscript of 10 is equals to 10 over 2 times 2 times 3 plus 10 minus 1 times 4 is 5 times 6 times 36 is equals to 210. Alternatively, but more tediously, we add the first 10 terms together. So, S subscript of 10 is equals to 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 31 plus 35 plus 39 equals 210. This method would be a drawback if we had 100 terms together. So, it is much better to use the formula than to use this kind of method. So, it will take longer time to finish, especially on larger numbers. So, arithmetic sequences. For sequences in arithmetic, find the common difference. So, 1, 1.1, 2.2, 3.3, 4.4, and so on. The common difference is 1.1. It's simple because we just subtract the first term and the second term. So, next is 41, 32, 23, 14, 5. So, by subtracting, we can have negative 9 as their common difference. It is negative 9 since the sequence are subtracting. I mean decreasing. Another example in the AP 10, 5, 0, negative 5, the common difference D is equal to 5. Justify whether the above statement is true or false with a solution. A subscript of 2 minus A subscript of 1 is equals to 5 minus 10 is equals to negative 5. A subscript of 3 minus subscript of 2 is equals to 0 minus 5 equals negative 5. A subscript of 4 minus A subscript of 3 is equals to negative 5 minus 0 is equals to negative 5. Although the given list of numbers forms an AP, it is with D is equals to negative 5 and with D is equals to 5. So the given statement is false. The second type of progression is geometric progression. A geometric progression is a list of terms as in arithmetic progression, but in this case, the ratio of successive terms is constant. In other words, each term is constant times the terms that immediately precedes. Let's write in the terms in geometric progression as u subscript of 1, u subscript of 2, u subscript of 3, u subscript of 4, and so on. An examples of geometric progressions is 10, 100, 1000, or 10,000, meaning they have a common ratio. Compared to arithmetic progression, they have common difference. In geometric sequence, each term is found by multiplying the previous terms by constant. For example, 2, 4, 6, 2, 4, 8, 16, 32, 64, 128, and so on. A sequence has a factor of 2 between each number. Its rule is x subscript of n is equals to 2 raised to n. Geometric progression. In general, we can write geometric sequence like this. AR raised to 2, AR raised to 3. R is the factor between the terms called common ratio. The rule is x subscript of n is equals to AR raised to n minus 1. We can use n minus 1 because AR raised to 0 is the first term. We have here an example. Example number 1. Find R for the geometric progression whose first terms are 2, 4, and 8. So, 4 over 2 is equals to 8 over 4 is equals to 2. Then, the ratio is R. Example number 2. Find R if the geometric progression whose first terms are 5, 12, and 120. 1 half over 5 is equals to 1 over 20 is equals to 1 half is equals to 1 over 10. Then the ratio is 1 over 10. Geometric sequence. For each sequence, it is geometric. Find the common ratio. Number 1, 2, 8, 32, and 138. So the answer is 4 because 2 times 4 is equals to 8. 8 times 4 is equals to 32 and 32 times 4 is equals to 128. The next one is 1, 10, 100, and 1000. So the common ratio is 1.1. Then 1, negative 1, 1, and negative 1. The common ratio is negative 1. And next is 20, 16, 12, 8, and 4 is not a geometric sequence. Since it is an arithmetic sequence, since there's no common ratio, the common here is that they have a common difference just like the arithmetic sequence, which is 4, so therefore it is not a geometric sequence. If we know the first term in geometric progression and the ratio between successive terms, then we can work out the value of any term in the geometric progression. The nth term is given by u subscript of n is equals to AR raised to n minus 1. Given the first two terms in geometric progression, 2 and 4, what is the 10th term? A is equals to 2, R is equals to 4 over 2 equals 2. Then u subscript of 10 is equals to 2 times 2 raised to 9 is equal to 1024. A geometric series is a geometric progression with plus signs between terms instead of commas. So an example of geometric series is 1 plus 1 over 10 plus 1 over 100 plus 1 over 1000 plus so on. We can take the sum of the first n terms of geometric series, and this is denoted by S subscript of n. S subscript of n is equals to A times the value of 1 minus Rn over 1 minus R. Given the first two terms of geometric progression as 2 and 4, what is the sum of the first 10 terms? We know that A is equals to 2 and R is equals to 2. Then S subscript of 10 is equals to 2 times 1 minus 2 raised to 10 is over 1 minus 2 is equals to 2046. Given the first two terms of geometric progressions and 5 and 1 half, what is the sum of the first 7 terms? We know that A is equals to 5 and R is equals to 1/10. Then S subscript of 7 is equals to 5 times the value of 1 minus 1 over 10 raised to 7 over 1 minus 1 over 10, then it is 5.55 approximately. So that's the end of the discussion about variation and progression. I hope you learned something from the discussion. Bye.